Here's Precalc. It's the lecture for 3.2.2. It's about area under the curve. And so this is, I'm going to do problem 3-101. And so it says Erin drove from Green Bay to Milwaukee for the first half hour. She drove through a residential neighborhood traveling at a constant speed of 25 miles per hour. As she entered the on-ramp of the freeway, she encountered heavy traffic. She was able to gradually increase her speed at a constant rate as the traffic slowly dissipated until she reached a speed of 75 miles per hour a quarter of an hour later. She continued at that speed until she got to her destination after a total of 2 hours of driving. Assume she made no stops along the way. Sketch a neat and accurate graph of the situation, being sure to label and scale your axes. Shade in the area between the curve and the positive x-axis. So this one you have to maybe think about it a little bit when you start figuring out your scale. But basically I got that she drove for 2 hours. So I made my x-axis time, and I just made it go out to 2, and then I split it in half and made 1, and that's a half hour. Okay, so, and then I looked at the highest numbers, like I looked at all the numbers for her speed, because it's kind of weird, but on the y-axis, it's going to be speed instead of, sometimes we have distance on the y-axis, but this time it's speed. So her highest speed was 75. So I just wanted my graph to at least go up to 75. So I counted by 25s. And it kind of works. And so then I'm just following, her journey. So she had a constant speed of 25. So constant means it stayed 25 for the first half an hour, 0.5 of an hour. And then she sped up at a constant rate for the next... that's going to be 15 minutes because you know how hours go, 15, 30, 45, 60. So she sped up at a constant rate until she reached 75. A quarter of an hour later, that's how I knew how far to make her, like I knew that she had to, that's a quarter of an hour later right here. And then she went 75 for... what does it say? Until she got to her destination after 2 hours. So she just went 75 all the way across, all the way down to 2 hours. Okay, so that is my model, my graph. And then it says, shade the area between the curve and the positive x-axis. So that's why you see this shading in here. And then it says, what are the units when calculating the area of the shaded region, and use unit analysis, or sometimes we call it dimensional analysis, to justify your answer. So that's when you do that thing where you cross off, like you do fraction math. So for instance, if I wanted to find the area just of, well, I don't even want to do that little piece. We're going to end up having to find the area under this whole thing. So we have to chop it up somehow. I got the idea that instead of chopping that little chunk off, I mean, you could chop that chunk off, but I just decided I wanted just 3 sections, so I chopped it this way. And if I want this, this part right here, I can just do length times width, or base times height. So that's going to be 2 hours times, this is miles per hour right here. So it's going to be 2 times 20, or 25 miles per hour times 2 miles, or sorry, hours. You're going to cross out the hours, and that gives you 50 miles. So to answer letter B, it says, what are the units when calculating the area? The units end up just being miles, because you're going miles per hour times hours. Miles per hour, so it's like hours in the denominator, times hours. The hours are going to cancel out, and this area here is going to give us miles, which is actually a good thing. So the next thing is that it wants me to calculate the area under the shaded region when x is between 0 and 2. Okay, so here's the x-axis between 0 and 2. I want the whole shaded region. I already found out that this part here, do it in pen, this part here, that's 50 miles. I know because I already calculated it. It was 25 times 2, because length times width, because it's a rectangle. Okay, and then I wanted to do the rest of it, so I made me a little triangle here. And I know triangles go like 1/2 times base times height. So this base right here, between 0.5 and this would be 0.75, that's 0.25. So it's going to be 1/2 times 0.25 times, the height ends up being 50 because we're going from 25 up to 75. So multiply that out on your calculator, you get 6.25. Okay, and then that leaves us just with this last rectangle here. And so this is 0.75 here, and this is 2. So what I did is I just asked my calculator. You could probably do this in your head. 2 minus 0.75. And I got 1.25. So this one's going to be, I even wrote it here for you, 1.25 times 50. Why is the height 50? Well, it's the same as the triangle. It goes from 25 up to 75. And so I get these three numbers. These are the three sections that I split the area into. So I'm just going to, I didn't do it yet. Let me add these together on my calculator. So I got 6.25 plus 62.5 plus 50. So that gives me 118.75. Is that what they want for letter D? It's 118.75 miles. And they're asking to calculate. So the area does represent miles. So that's actually how far she went. Like, because they only told us how long she spent driving at certain speeds, but now we know how far she went. It was 118.75 miles, and so that kind of answers letter D. So this whole idea, I'm going to take like just a little minute to talk about area under the curve. This is in your math notes box. And it says many of the ideas in this textbook and in future mathematics courses are related to the area under a curve. So basically calculus. Mathematically, area under a curve is the area of the region that's bounded by some function, the x-axis, and two vertical line segments located at A and B. So that's our little interval where x is in between A and B. The notation area of a function between A and B, well, where x is in between A and B, will be used to denote the area under the curve, y equals f of x, over the interval, x is between A and B. If f of x is 9 minus 2 to the x, then the area of the function, where x is in between 2 and 3, is equivalent to the area of 9 minus 2 to the x, where x is in between 1 and 3. So it's weird notation, but this is just an idea that you need for calculus. And there's going to be another video about the next problem.